Hi, my name is Swarndeep Singh. I am a SQL Server DBA, and today I am going to talk about SQL Server TDE and its implementation in SQL Server. So what is TDE? TDE stands for Transparent Data Encryption. It is used by companies like Microsoft, Oracle, IBM in their database products to encrypt data files. There is a non-compliance data at rest. So this technology, transparent data encryption, satisfies that compliance. TDE was first introduced by Microsoft with SQL Server 2008. TDE is available with Enterprise Edition. It is also available with Developers Edition and Evaluation Edition. Back in SQL 2008 R2 and SQL 2008, Data Center Edition also had this feature, which is no longer exists in the newer versions. So how TDE works? With TDE, database files are encrypted, hence prevents the data files from being exploited if data files are backed up are or copied out with bad intentions. For example, if a SQL Server has a database which is encrypted using TDE, someone copies the data files, log files, or even backup images, they cannot utilize that unless they have the certificate and the private keys. If they want to attach the data files to SQL Server, they can't do it. And if they want to open the data files in Notepad or any text editor, they can do that. And if they try to restore, they still can't do that without the certificate. So it's a good protection as long as it is related to data files only. So we'll see next how or what we can do, what limitations we have with TDE, and how we can keep it secure in case just we need it for recovery. These are some facts for TDE. For backups, if compression is enabled, probably you won't see much benefit of compression. Generally, Microsoft recommends that encryption and compression both should not be enabled together. Compression will, as compression's logic is different, it tries to deduplicate data in the data files to reduce the file size. With encryption, compression cannot do much. So keep that in mind that if you're compressing the database without encryption, with encryption, data file or the backup file size will increase significantly. If any of the database is encrypted on an instance, TempDB will anyway get encrypted. So for example, if you have 100 of databases on one SQL Server, only one of the databases is encrypted, TempDB will have to be encrypted anyway. So if you have, let's say, out of 199 databases not encrypted, and if those databases have to use TempDB, those databases may see some performance impact. So keep that in mind also when you are planning for TDE. In any database, if there are file groups which are read-only, you cannot enable TDE. If you try to enable TDE, it will fail. So make sure that you don't have any read-only file groups for the database. Once TDE is enabled, the mirroring and logship databases on the other side will also be encrypted because they follow the transaction logs, and TDE encrypts the transaction logs. About certificates, TDE is a certificate based, so each certificate has expiry date. Even though any certificate expires, that doesn't mean that TDE will stop working. SQL Server will still honor the certificate, though you can either renew the certificate, or when first time you create the certificate you can have longer expiry date, or if you have compliance to have certificate rotate every year, in that case you have to regenerate the certificate. And when you regenerate, typically it is redoing the encryption. So using the expiry underscore date option while enabling the certificate or while generating the certificate, you can put a custom date or custom expiry date. By default it is 1 year. From the hierarchy point of view, how encryption is taking benefit from operating system, the operating system has inbuilt APIs. So when you first time install SQL Server on a operating system, the instance have one master key, service master key, which will be encrypted by data protection APIs or operating system level protection APIs. These service master keys are the root of all encryption. So when you encrypt database master key on master database, it uses service master key for the encryption. So database master key is a master database, or it is in the master database. So any certificate which you create on master database uses the database master key. So when you have to create a certificate for TDE, you have to have database master key encrypt that certificate. Once you have certificate, it is used by all other databases to generate database encryption keys. So database encryption keys are actually mapping between the master certificate and the databases. So databases finally take advantage of DEK or database encryption key to encrypt the entire user database. Implementation of TDE is very straightforward procedural task. First, you create the master key on the master database, then you create the certificate, and the certificate has to be protected using the master key. This certificate is on the master database. Let's keep that in mind. That's why it's called master database certificate. Once you have master certificate, then you have to have a database encryption key which will be encrypted using the master certificate. Once you have database encryption key, then you're ready for enabling the TDE on the database. So each database has its own DEK or database encryption key. You cannot have one database encryption key and have all databases encrypted. Every time you have to encrypt a database, you first have to create the database encryption key for that database. So once you enable encryption for database, then everything runs in the background. So the data files starts getting encrypted, starts going through the process. It is called onboarding encryption, which takes some time based on the size of database, based on the data type. You can see the status, how it is doing. We'll see in the next slides. Last but not least, you should back up your certificates and private keys at the safe place. You definitely need it in case you have to have a situation where you have to recover the database. Without a certificate or without certificate and private keys, you cannot recover the database. So now a couple of slides are for the demo. So I will skip the slides and go directly to the SQL Server demo. I have a virtual machine here. The very first thing you have to do is to create the master key as we discussed in the slides. So let me go through it. The master key is in the master database, so definitely you have to use master. In case you won't use it, then probably you won't be able to create it. And it is also encrypted by the password. You should use a strong password here. So let me execute it. So it has created a master key on the master database. So next step is to create the certificate. So when you create the certificate here, we are not providing any any password because it is by default encrypted by master key. So we have syntax, create certificate, name of the certificate, and a subject. Let me execute it. Okay, we have certificate now. If you want to search for the certificate is there, you can run a query here. I should have a query down here. Okay, so now you can see the certificate here. Whatever options we specified, you should see here. For example, it has subject that we provided, encrypted by master key. So making sure that we have the certificate in place. Now, as we discussed earlier, the mapping has to be done between database and the certificate. That is called the database encryption key. This encryption key is not only mapping, but it is the algorithm and also the size of the algorithm. So we are using AES 256 algorithm here for database encryption key, and also we are specifying here that we want to encrypt this database encryption key with the certificate we created here in this step. So let me execute this. Alright, there's a warning. It's just a warning. Every time you create it, it will show you the same warning. It tells you that you need to back up your encryption, your certificate. So if you lose your certificate or you don't have certificate, you cannot recover the database. So I'll jump to the certificate backup here. So let me delete my old certificates. I did it before the demo. I created samples. Okay. The backup certificate has typically two files. The first file is the certificate itself. The second file is a private key, which is used by the system to decrypt the certificate. And the private key, for the safety of the private key, we are encrypting it with a password. You can see here. So we should have two files now. One is for certificate, other one for the private key, and both of the files are needed in case you have to recover the database. Alright, so let's check here. Okay, we have private key and certificate here. If you want to open the certificate, feel free, you can read it. As we didn't tell any expiry date, it is by default 1 year. You can see here. And also whatever information we provided is here. There are some details. You can go through the details, but nothing that you want to look into it. It's just a certificate, and you can keep the certificate and the private key at the safe place. So we have certificate, we have database encryption key, we have backed up the certificate as well. Now the last step is our database. Name is TDEDB. We want to set the encryption on. It's a simple command, just set encryption on. You already have database encryption key, so database SQL Server knows that which DEK to be used. So I'm starting it. It's done. It just changed the flag. So in the background now, it should be encrypting the database. If you want to check the status, this is the DMV sys.dm underscore database underscore encryption underscore keys. So let's execute this query quickly. Alright, you see two entries here. The first entry is for TempDB. You can see here database ID 2, which is for TempDB, and this is number 7, which is for our database TDEDB. So it is being encrypted, and when we executed the query, it was 12% completed. You can run it again to find out the status. Alright, I'll let it run and resume the demo once it is completed. Okay, looks like it's almost completed. So let me see. Okay, the percent complete is now 0. 0 doesn't mean that it is not encrypted. 0 simply means that it has completed the cycle of encryption. And the state, encryption state here is 3. You can see from the mapping here that 3 is encrypted, and if it was 2 it should be encryption in place. So why it is 0? The question is, it is 0 because if you have a large update on database, or you have bulk inserts, then that has to be encrypted again, and you can see the process here. So that's why once it is encrypted, it goes back to 0. That's pretty much it is. Now you have encrypted database, and you take the backups, make sure at your DR site or wherever you want to restore it, you first create the certificate from here. You have to restore the backup file from here. Going back to my slide show. So we talked about certificates, DEK, TDE, then backing up the certificates. You have any questions? Please visit my blogs, talksql.blogspot.com or www.swarndeep.com, and you can leave your comments in case you have any questions.